Okay, so for our next assignment, we'll be getting in more into similarity, um, expanding on our ratios and similarity that we've already talked about. So the key things, if we're talking about similar figures, all the corresponding angles are congruent with triangle, quadrilateral, etc. And all the side lengths are proportional. When we say proportional, that means the same proportion for all corresponding sides. So each ratio must be the same. In other words, as it says, in other words, each ratio of the corresponding sides must be the same. 4 to 3, 4 to 3, and 4 to 3 if there's a triangle. Or if there's a pentagon, big to small, 5 to 2. Every one has to be 5 to 2. You can't have one that's 5 to 3. Then it's not similar. Okay, so each ratio of corresponding sides must be the same. Okay, now, just like congruency, that would be the same idea with congruency, except for these would be congruent instead. So instead of proportional, it would say congruent if we're talking about congruent figures. Remember, that's 6 corresponding parts, like say if we're talking about triangles, for example, right? But just like in proofs, for triangles, we only had to show 3 sides were congruent, 3 pieces. You had SAS, SSS, ASA, AAS, and HL theorem. Okay, so we only had those 3 of those 6 to be in a certain order, and then they'd be congruent. Well, we have the same idea with proving triangles similar. Okay, instead of having 5 ways like we had with the 5 ways I just mentioned of proving triangles congruent, we have 3 ways of proving triangles similar. We do not have to show all 3 angles and all 3 sides, all 3 angles congruent and all 3 sides proportional. We can just show one of these 3 ways. Okay, so we looked at AA today in class with the overlapping triangles. Okay, it doesn't have to always be overlapping. We'll see other ones here that aren't overlapping. But if we can show AA, that means 2 angles, corresponding angles are congruent. And really, AA, as I mentioned today, was AAA. All 3 corresponding angles are going to be exactly the same in both triangles. So if you can show that, then they are similar. They could remember similar includes congruent. So if the sides were all equal, okay, the corresponding sides were all equal, then it's actually congruent. So congruency falls underneath similarity as well. But remember, similar we talked about today is usually bigger or smaller. If it's bigger, it's called an enlargement. If it's smaller, it's called a reduction. Okay. Um, and that ratio of like 5 to 2, like I was saying, that's called the scale factor. Okay, and when we talk about this, when we look at the problems down here where it says give the scale factor, it's the same thing as the ratio from one triangle to the other. Okay, so um, you're going to call it scale factor, and then you can see it as SF, written SF for scale factor. Just know that. The ratio from one triangle to the other is the same as the scale factor, the same thing, and it can be written as SF for scale factor, capital letters. I've seen it. All right, so the other way besides AA is SAS. So again, just like SAS incongruence, the A must be between the 2 sides. Remember, we call that included, we call the middle one the included piece. In this case, it's an included angle. And that's why you see right here, the included angle must be congruent. Anytime it's dealing with angles, anytime you see A's in any of these, they have to be congruent. Remember, the S's are the only ones that have to have the same ratio for the corresponding sides. Okay, but A's must be congruent. Okay, so the included angle must be congruent, and the 2 sets of corresponding sides must be proportional. In other words, the 2 sets of corresponding sides must have the same ratio. Okay, and lastly, you could prove it by just having 3 sides given to you in both the small and the big triangle. Okay, and then again, all 3 sides must have the same ratio. Corresponding sides must have the same ratio. You need to make sure you check all 3, not just 2 of them, because there's going to be cases where 2 of the 3 that you check are going to have the same ratio, and you think, oh, that's good enough, I'm going to stop there. No, you need to check all 3, because the third one could be different and not work. Okay, guaranteed to be on the DCAS. Okay, it's usually either SAS or SSS. Oftentimes, if they're talking about, want you to check for the ratio of the corresponding sides. So that's why it's usually one of these 2. Okay, but it can be this. and it may not deal with, so they're not going to be concerned about side lengths at all. That a perfect example of that one is this number 3 here. If you saw this, it says, so let's read the directions. Determine whether the polygons are similar. So we're looking to show one of these 3 ways right here. If so, write a similarity statement. Remember, a similarity statement would be like a congruence statement, except for you have a similar one in between the 2 triangles. Okay, which I have as an example right there. So instead of being a congruent symbol, it's going to be triangle, whatever. In this case, ABC is similar to triangle DEFE. Okay, and give the scale factor. So it's yes or no. For similar, it's if it's similar, you write a similarity statement and give the factor. If not, you explain why it's not. Okay, so that would be if you're looking at these cases, these 2 cases here, you'd see that the ratio of one pair of the corresponding sides was not the same as another. Or if you're dealing with AA, you'd have to show that 2 of the 3 angles were different. Okay, they're not all the same. All right, so let's look at some examples here, and this will help you for your worksheet. A couple of them down here coming right from your worksheet. They're numbered differently, but they're on here. But this is the examples, the types you can see, and what you do. Now I'm going to add one piece to it. Even though it says these directions, if the answer is yes, not only do I want you to write the similarity statement and give the scale factor, I want you also to say by which of these 3 ways do we know that they're similar. It's going to be one of these 3. That's the only choices you have. It's not 5 like congruency, only 3. So look at the setup I have. Notice I have SAS, SAS. So if they're similar, I already know it's by SAS similarity. And that's why you see the answer yes by SAS similarity. Okay. So the angles are congruent. Remember, the angles must be congruent. Okay, so they're both 90 degrees. And now I check the corresponding sides. 10 to 5 has a ratio of 2 to 1. 6 to 3 has a ratio of 2 to 1. So both the ratios of the corresponding sides are congruent. So now we can say yes, they are similar by SAS similarity. So I write my similarity statement. ABC, triangle ABC is similar to triangle DFE. I purposely did that so you don't think, oh, they're just going alphabetical order, A, B, C, and D, E, F. No, D, E, F would be wrong. Okay, make sure you pay attention to the order, D, F, E. Okay, and the scale factor, that's the same thing as the ratio. Remember I told you that. If I do the ratio, it's 10 to 5, or I reduce it always. I always have to simplify it down to 2 to 1, and obviously 2 divided by 1 is 2. So they might have you write it in ratio form, or you just divide the 2 numbers. 2 divided by 1 is 2. Okay. Number 2. Um, Originally, I was going to just have just these 2 angles here and not the side lengths for you to check as well. So first, let's pretend as if these side lengths aren't here. Okay. We just have these 2 angles and these 2 angles. Well, if I originally look at these 2, I say, well, I see a 49 and 49, but these are different. So you might be thinking, oh, automatically not similar. Okay, well, you would have got nailed because you need to find out the third side. You would have found out this third side is the 43 that goes along with this, and you'd find out this third side is 88, which matches up with this. And so they are similar by AA similarity. Okay, all 3 angles are exactly the same, meaning the corresponding angles, that is. Okay, so like I said, it originally looks like no, but it is by AA similarity. Remember, that's the one I told you that DCASL uses the same thing as AAA, because if 2 of them are the same, the third one will also be the same. Okay. Um, so I can write my similarity statement. 88 is going to match up with 88. So B matches up with H. B matches up with H. 49, D matches up with J. D must match up with J. And the 43 matches up with the 43 here. So C matches up with I. C matches up, corresponds with I. Okay. It doesn't matter the order. I don't have to say B, C, D. You could have said D, C, If I say DCB, then you must say JIH, corresponding order. Okay, and so now let's go ahead, and now that they have side lengths on here, we need to make sure, now we can also go by, let's say we just want to check slightly they didn't have any angle measures here. Okay, let's say they had no angle measures. They only had the 6, 9, 12, the 6, 4, and 8 here. Well, then we'd be checking to see if it's similar by SSS, because they gave us the 3 side lengths. Okay, I have to put them in order, okay, and match up the correct ones in order. Okay, so the longest here is going to get matched up with the longest here. So I have 12 over 8. So here I have down here to check by SSS, 12 over 8. Middle to middle, 9 over 6. 9 over 6, and the small to the small, 6 over 4. If you simplify all of these three ratios, they all simplify down to 3 over 2. So yes, they are similar by SSS similarity. Okay, and obviously we already checked it by AA similarity. Okay, you're never usually going to have both of these situations given like this. This is unusual. You will not see this on the DCAS. They will only give you enough to do one of these three. So either give you all 3 sides and no angles, or they'll give you 2 sides and an angle, 2 sides and an angle, included angle right here, or it's going to be by AA. They're on the DCAS. They'll never give you all this information. That's too much. Okay. They want to check to see that you know what these 3 look like and how to check them. Okay, so we've checked them, both the AA similarity and the SSS similarity, on this one particular problem. You would not have to do that. You'd have to just choose one or the other to prove it to be true. Okay. All right, number 3. Notice there's nothing, not a single angle marked here or side length, and they can still ask you if they're similar, because for now I couldn't check side lengths, so obviously I can't do SSS or SAS because I have nothing to know about their side lengths. So the only way I could check it is to see if it's AA similarity. Well, I should know that vertical angles are congruent. I have that's congruent. Here I have parallel lines cut by a transversal. What did I say? The first one of the 3 or 4 you should be looking at. AIA. There's alternate interior angles theorem. So these 2 are congruent. So we already have the AA and we're done. So it is similar by A, but obviously I have parallel lines cut by this transversal, and then I have alternate interior angles there. I won't mark it, but you could have marked that one as well. And you see you have AAA. Okay, so yes, without even having any angle measures identified or silenced, they can still ask you if they're similar as long as they have parallel lines, for example, and then cut by transversal, and then you have AIA theorem to use. Okay, and that's what it states right here for you. All right, so that's the 3 key ways that you're going to be checking, okay, when you're dealing with those particular problems of whether they're similar or not, what you're looking for. Okay, so let's look at a couple other problems that you could have that are going to deal with similar, that aren't just set up like this situation right here. And this is a common one, number 5, that you'll see. It's on your worksheet as well. It's just renumbered to a different number, but that you can see on the DCAS. Okay, this has been on the DCAS before. Okay, just different numbers. All right, the 2 triangles are similar, so they're telling you the triangles are similar. Now, did I need to be told that? No, I could look right here. I have AA, and we're talking about this big triangle and this medium-sized triangle right here. We're not talking the individual ones inside of them. We're talking these right here. Okay, I don't have to be told that because I see a AA similarity. And of course, the third A's are going to be equal because I have vertical angle theorem right there. Okay, so you can see that those are going to be the same. All right. I wouldn't even have had that. They could have been separated and been fine because these 2 angles add together from 180 is going to give me the same answer for this angle as these 2 angles add together, subtracted from 180 is going to give me the same answer here. So it didn't even have to be connected like this. All right, so they are similar by AA similarity. Okay, but it didn't ask you to identify that. Just says find the missing variable. So the key here is I set up my proportion correctly. Remember we talked about it in class today on the worksheet you did yesterday. / today, because I'm sending it out today anyway, this video, is they told you what sides to match up. I told you from now on, they aren't going to tell you that. You have to be smart to figure out your corresponding sides correctly. So again, I've talked about this before, how we can recognize it. So if I look at this 15 first, notice that's next to the one arc. So I go to the one over here that's next to the one arc. That's 10. So the 15 matches up with 10. That's why I have 15 over 10. I'm going left to right. Okay, so that means over down here I have to go left to right as well. So on this one on the left, it's next to the two arcs, and this one is next to two arcs. So m plus 4 over m. Now remember we learned today in class the three different ways of solving proportions. And so I'm going to go ahead and use the shortest way as possible, which means this does not simplify, but this side simplifies down to 3 over 2. I can put this underline in here, fraction. Okay, and then I'm going to cross multiply. So I get 2 distributed through there. Remember, I noticed I didn't have the parentheses here, but I put them in here. So I make sure that I distribute it through here. 2m plus 8 equals 3m. Subtract the 2m across, you get m equals 8, and I'm done. Not very hard. Okay, the hardest one on here is this type right here. Okay, and you have a few of these problems on your worksheet. You want to enlarge a 3-inch by 5-inch photo. So here's, I didn't put the units on of inches, I just put the numbers. Okay, pretend this is 3 inches by 5 inches. And you want to blow it up as big as you possibly can onto a paper that's 8.5 inches by 14. Dang it, I wrote the wrong number. So this calculation over here is wrong. Okay, it should be 14. So let me change that. 14 divided by 5 is 2.8. Okay, so good thing I reread the directions again, as I keep telling you guys too. Make sure you go back and read it. Make sure you're using the right numbers. Okay. All right. So how I go about it. Okay, I can either increase this as much as I can. This 3 corresponds to the 8.5 side, or the 5, the length, corresponds to the 14 side. Okay. Well, if I want to use up this 5 all the way to the 14, that is 14 divided by 5, which is 2.8 times. So this would be, both these would have to go up 2.8 times. 2.8 times would fill up that 14 all the way. But notice if I multiply 3 by 2.8, oh, that will work because I have 2.83 repeating bar. So therefore, I can multiply 3 by 2.8, and that'll cover all of this, and it'll just go down to maybe like right here with a little skinny piece left. I'm trying to maximize the space that I have right here. Okay. Now, so when I divide this 8.5 by 3, I get 2.8333. So that means if I move this 3 up as much as I could, to be 2.83 times to fill up the whole 8.5. Well, the problem is why I can't use that one is because this 2.83 repeating bar, I didn't have a repeating bar to put on it at the time. I could put one on right now. Okay, repeating bar. Is too much for this length. It means it would go past the 14, because remember 2.8 maxes it out at 14. So 2.83 would make it come out to like right here. Well, I can't go past this. So after I divide the two corresponding sides to find their ratios, I have to take the smaller of the two, always, because I can't go past that paper. If I did 2.83 times 5, that's more than 14. I can't go past the 14. So it's always, after you find the ratio, you divide them, get the decimals, you take the smaller of the two. And so therefore, I'm going to take that 2.8, multiply it by 3, and that 2.8, and multiply it by 5. And that will give me the new dimensions. So what's the largest size of the photo? Well, we already know the 14 divided by the 14, using this 5 here, it will go ahead and max out the whole 14 inches right here. Okay, but 3 times 2.8 is 8.4. Okay, so 8.4 inches by 14 inches is the maximum, is the max. Okay, I multiplied both of these by the 2.8, the smaller of the two, and it gives me 14 inches and 8.4 inches. And so that will fit on this 8.5 by 14. There'll be just a little bit, a little 0.1 inches left on the top or the bottom, whichever they chose. Okay. Or they could have actually centered it and had 0.5 on each side technically. Uh, Not 0.5, but 0.05. There's only 0.1 left. Um, all right, so that's how you do these ones, and you'll see a few of these on there. Let me see. I think that's it. Yes, that's it. Okay, and that'll end it.